for operating system. Today we are going to see the gate question based on the first bit and best bit memory allocation concept. Let's go over the problem. The previous session I explained about the various memory allocation algorithms. Please kindly check the video sequence when I have doubt, and please share the video if you like the concept. Let's go for a problem today. The problem given here, this is pointer. A problem given here. The sequence of requests for blocks of size various are 300k, 25k, 125k, 50k can be satisfied if we use which one? Whether use best fit but not first bit, or first bit but not first bit, or both, or none. So we have to find out the answer now. Let's look for a diagram and explain. So here let's say the first process called P1, P2, P3 and P4 here continuously. These all come under the continuous memory allocation concept. Let's they have a diagram with having the memory space of 150k and 350k. These are free, remaining are occupied. This occupied, this occupied, this occupied. So now let's see apply the first fit algorithm. So first fit algorithm, first we'll check where possible. P1, the P1 size is what? It's the pointer. So where P1 that is 300 KB, so we can accommodate here, because if we accommodate P1 here, remaining 50 KB will be there. So 300 PP can for P1 accommodate here. So memory space available, so we can allocate. Then P2 is 25K. So 25 P2 size 25K, already have 125K is 150 KB is there. So P2 can allocate here, remaining 125 will be balanced. So here this P3 how much? 135. So P3 you can accommodate. So wherever possible you can accommodate the memory region. So P3 also P2 accommodate and P3 accommodate. Now P4 is there. P4 how much? 50K. Already here 300 over, remaining how much is there? 50 KB will be there. So this is 50 KB allocated is sufficient for allocate the P4 here. So as per the diagram, what happened? P1 can accommodate, P2 can accommodate, P3 accommodate, and P4 also accommodate. Now you can apply best fit. Is it possible? So best fit means what? Wherever apply, the memory should be visible. That's the condition. So first P1 says 300 KB, 300K. So here 350 is there, so we can accommodate P1 here. Remaining how much is there? 50 KB will be there. Same. Now P2. So P2 what happened means 25K only. So if you accommodate P2 25KB, remaining 125 will be unused. So it's not the second step be a best fit. So we can try another code. Otherwise, where here we how much is the 50KB is there? So here, so P2 can accommodate here, because already for how much the 50K is the balance. So out of 50K, 25 is go for P2, remaining 25 left here. So P2 I can accommodate here. So P1 accommodate here, P2 accommodate here, and P3. Now question is P3 how much? 125. Here already 150 is there. So I can accommodate 125 here P3. So balance how much? 25K here. Now what about P4? So P4 total 50K is that here we have balance of 25. Here also we have 25 KB. Is it possible to means? Not possible. Various places there, because these are come under the category of contiguous memory location concept. So here for first bit it's suitable for this concept, for all the process allocated properly and working fine. But best fit not possible. P1 accommodated, P2 accommodated, P3 accommodated, P4 not possible. So this is called one more way of creating external fragmentation. We already discussed here the previous class, external fragmentation. So first step is suitable, best step is not suitable. So let's conclude the answer here. That is B is the right answer. So for this question, B is the right answer. So whenever ask the questions, please concentrate and write it based on that one. Memory management can solve the problem very easily. If you have any queries or suggestions, please kindly communicate with the following social media. And thank you for watching the video. Please like, share, and comment. Thank you.